first page here, we talked about parts of a power. On the next page, we talked about what to do if there wasn't an exponent written in. You know, that's automatically a 1. On the next page, we talked about PMA. Power to a power, we multiply. When we multiply our bases, we add. And then on that next page, we've left it blank. This is where we're going to fill in today. We are talking about dividing, so we're going to start by adding in some rules here. We're going to write in, when dividing powers with like bases, if you treat the division bar like a giant subtraction sign. It'll all make more sense here when we get some examples in. But I want you to start by writing this down. When dividing powers, with like bases, treat the division bar like a giant subtraction sign. So when dividing with like bases, we're going to treat the division bar like a giant subtraction sign. So I want to give you an example to show you what I mean. If we have x to the 9th divided by x cubed. Clearly we're dividing, right? We have that division bar. So when we divide, that division bar looks like a big subtraction sign, doesn't it? So we're going to subtract our exponents. We're going to take it as 9 minus 3. 9 minus 3. X to the 6th power.
Could it go in
Yes, you could have had x cubed divided by x to the 9th. You got x to the negative 6th power. And there is another step you would have to take with that. We'll learn that next. So that's our goal for today, is to talk about dividing powers. And when we divide, we are going to subtract those exponents. Now you still have to remember about the PMA. Power to power, you multiply. When you multiply your bases, you add. Because what we're going to do is take all three of those, really the three rules, power to power, multiplying our bases, and then division. We're putting all those three things together today to simplify our exponents. So I'm going to give you guys a note sheet, and we're going to go through some of these examples together. Yes, we've done writing in our books. Okay, we still keep those books out because we think it'll be helpful to see. What's that?
I thought they were passing it back to Ashley.
So let's start with example 1 here. You guys have the same thing I've got on my paper. We're clearly dividing, aren't we? What do we do to our exponents when we're dividing? Subtract them. But before you do that shortcut, let's talk about why that happens. What is x to the 4th really?
X times X times X times X.
X times X times X times X. Everybody agree with that? And then x squared is really?
X times X.
X times X. Now, when we're dividing, we try to cancel out, don't we? Well, we can cancel out 1x in the numerator with 1 in the denominator. We can cancel out another 1 from the numerator and denominator. Well, how many x's are we left with? 2. So we would write it as x squared. And of course, there's an easier way to get to that answer, isn't there? Instead of writing that out, we would take 4 minus 2.
Wouldn't x squared be the same thing as saying 2x?
No.
'Cause
2x would be
it's
x plus
oh,
x.
that's right. Yeah. It's 2x. Yeah.
Now what about example 2? I want to write this out again. X squared really means x times x, right? What about x to the 5th?
X times x times x times x times x.
X times itself by x. So then we can start canceling these things out. Guys, please write these down with me. 1x from the numerator and denominator is going to cancel out, and so is another. Well, we're left with 3x's, but where are those 3x's located? Do you think that is significant? Well, the x is in the denominator, right? So we're going to write x cubed in the denominator. What are we going to put in the numerator? 0. That would make the whole problem 0. Put a 1. Put a 1. Now, what if we used our subtraction rule that we just talked about? What is 2 minus 5?
-3.
How did I get that down to the bottom? What do you think that negative exponent is going to mean?
You gotta do it again.
See what I'm saying? When we take x squared, 2 minus 5, it's going to give me x to the -3 power. Which this answer and this answer are the same thing. What do you think that negative exponent is indicating? Think it's going to go on the bottom? Let's see. Look at example 3. Can we use our shortcut here? Okay. So look at your a's. A to the 4th divided by a squared. What is 4? It's a to the 4 minus 2 power. And then b to the 5 minus 7 power. Well, what is 4 minus 2? 2. So really we have a squared. A squared. B to the -2. Now in that last example, when we had a negative exponent, where did we write that x? So this time we have a negative exponent on the b, so where are we going to write the b? On the bottom. What about that a squared? It doesn't have a negative exponent, so it's going to stay at the top.
And number 2, what is right for a positive x?
Right here? Well, this one I was just using the cancel out method to show in my x's left, we're left in the denominator. And x times x times x is x cubed, I just wrote it in the denominator. Actually, this answer right there will be transformed to that answer when I move it to the bottom.
I wasn't sure if it was supposed to be negative.
No.
So do we have to put it in a fraction for our final answer?
Yeah. You cannot leave a negative exponent in your final answer. And really, I don't think you'll have a lot of those today. Look at the next example, number 4. Let's use our exponent rule that we just learned. Now, x to the 4th, is there anything I can do with x to the 4th? No, so it'll just come across. X to the 4th. Go to your y's. We have y divided by y. What happens there? They're going to cancel each other out. What about the z's? 3 minus 1. Because remember, this z down here in the bottom doesn't have an exponent. So it automatically gets a 1. So 3 minus 1 is 2. So we have x to the 4th, z to the 2nd.
So would we have to put that in a fraction?
Do we have a negative exponent?
No.
No, so we don't need a fraction. We only need a fraction if we have that negative exponent. Now example 5 is a little bit different because we do have coefficients, right? So let's think, what goes into -2 and into 6?
3 or 1 or 2.
2 does. 2 goes into -2 how many times? -1 time. And 2 goes into 6 3 times. So we have -1/3. Let's go through our variables. I'll just set my line here. We have x to the 4th divided by x cubed. So when we divide, what do we do with those exponents? Subtract. So 4 minus 3. Now, the y's, there is a y in the numerator and denominator, they're just a little bit out of order, aren't they? See them? So what's going to happen to those? Those y's are going to cancel out. Y divided by y is going to cancel out. Now with the z's, I have z to the first divided by z to the second. So it's going to be z to the 1 minus 2 power. Be negative 1. So let's clean this up a little bit. We have negative 1. Excuse me, divided by 3. We have x to the first power, and y, or excuse me, not y, z to the negative 1 power. Now, we don't want to leave a negative exponent in our final answer. So what do you suspect is going to happen to the z? Okay, he's going to go to the bottom. So we write this out. We have negative 1x in the numerator, and we have 3z in the bottom. Now, when I wrote that in the denominator, what happens to that negative exponent? It's going to turn into positive. Look at example 6. Now, in this example, we have a lot going on. I would still recommend you using your order of operations. So I would clean up the inside of the parenthesis first. Now you will notice it looks like there's a negative above that 3. Do you see that? That's not really there. Okay. I think it was just a line that got added in by accident. It should not be there. So let's look inside. Is there anything I can do with 3 and negative 2? I'm looking at my coefficients. No, so I'm going to bring those across. What about my x's? I have x to the first divided by x squared.
X to the first minus 2.
So 1 minus 2. What about y's? 2 minus 3. Now that z, I don't have anything to do with it, so where's it going to stay? I'm going to leave it down in the denominator. It doesn't have anything I can do with it. Now let's clean this up a little bit. It's all still to the 4th power. So we have in our numerator 3x to what power? Negative 1. Y to the negative 1 divided by negative 2z. All raised to the 4th power. Let's keep going. Now, what can I do with this x to the negative 1 and y to the negative 1?
Drop them down to the bottom.
Okay, let's move them down to the denominator. They have negative exponents, we know we're going to move them down. So we have 3 divided by negative 2, x, y, and z. I'm going to put them in alphabetical order.
Wouldn't you put z up the top since it wasn't a negative?
No, it's going to stay put. The only time it's going to change is if it has a negative. I'll leave it where it is.
So z's already done with the 2.
Right, because the original problem I had z in the denominator. It's going to stay in the denominator because I can't do anything to it. Let's stay put. Now in our next step, we can't take everything to the 4th power, can't we? So we have 3 to the 4th. We have negative 2 to the 4th. X to the 4th. Y to the 4th. E to the 4th. What is 3 to the 4th power? What's it? 81, that's right. Divided by negative 2 to the 4th power. Not negative 16. 16. X to the 4th. Y to the 4th. C to the 4th. Whenever you're given a problem you really don't know where to start, I would recommend you using PEMDAS. Do you remember that? Please please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. I want you to use that process. It will help you, because like here we start with our parentheses, we simplified everything, then we took care of our exponents, we didn't have any multiplication. I want you to try that last example on your own, please. When you've got your answer, raise your hand, I'll give you today's homework. Is it a negative exponent? Is negative 2 an exponent? No, so it would be. Is this, did you do this one? That's what I asked you, if you did that one. There's two sides we're going to do on page 11. We take negative 2 to the power because that's not excellent. You're right, just 4. Also, you can simplify that. It goes into 8 and 64. Just change what you like. Yeah. Where's your answer? So you simplify. First, let's cancel that. D reflects in the denominator. You do think it's what stays in the denominator. And then we're going to change 4s. So we have a negative exponent. Now, if we get to the third power. So negative 1 to the third power is negative 1. What do we do? 3 times 3 is, no, it's just an 8 or 9. Look out. Yeah, so we're going to do a 3 to the third. Okay, Chris? Well, try it. You're not going to look at me. Just try it. Come on. A little effort in. You're not going to work. I'm going to send you to the office. You're not. What's wrong with that? That explains it to me. Oh. I think it should be true. If you put negative 1 in the third power. Negative 1. Yes, that's okay. Just the exponent. Here's, I'm going to give you about 2 more minutes to try it. And then close. 2 to the third power. So much. 2 is 2 times 3. So give you 2. And then you take negative 1 to the third. It's negative 1 times negative 1. It's negative 1, which is guys, on your worksheet, we're only doing page 11. There is a back that looks similar, but we're only doing page 11 for today. This D doesn't get to go to the numerator. It stays down here. It's down here in the blue name, so it has to stay down there. So then, move this D down as well. Erase it from here. Now, 4 cubed is not 12. 4 times 4 is 12. Which is 4 times 4 is 4 to the third power. Finish with the worksheet. Now, these guys, there's no reason to read them for calculator. It needs to start here. And the only way you're really going to change 4s like that is if they're negative. No, put this in, you need to multiply. Power to power multiply, so 3 times 3 is your B though. You had B at the first. Okay, you had already multiplied those, I guess. Yeah. So what about your D? Where should it be? Then it should be D to what power? Well, you're going to do 4 times 3, which is yeah, you need to simplify it. Negative 64. What goes into negative 8 and what goes into 64? 8 goes into 8 how many times? It's not 64 divided by 8, it's 8 divided by 64. 5 is high, and hence this 8 went to 64. Now there was a negative in there, carry across. That's right.
So it doesn't matter.
No, the rule is exponents. I think exponents this thing. And negative 8 is on it. So you're good. is really like multiplying 2 times 1. Okay, so that's 1, so they're just really hard.
So these two are
They do cancel each other. Please. No.
Oh,
We have the
okay.
same base, but we do that. It's fine. It's good. No. What have you got? What are you going to say? Which book? Give me that page number. We divide by the same base. What do you do with the rest of this? Okay, so you have the same base in number 1. So divide by here, what is 5? No, it's 5 to the third power. It's 5 plus 3. Use your calculator for that. We're only doing AG level. Not gonna do 12%. What have you got? Your exponents are right on the variables, but your coefficients are not. You're taking it all to the 4th power, should be taking it to the 3rd power. Negative 1 to the 3rd power is going to be negative 1. What is 2 to the 3rd power? Two caret 3. Go on page 11. Page 12.
Sure.
Yeah. What'd you get?
Still got some cheat sheets.
Huh? You want to try it? Help? You want my help? It's up in here. You got something to read. I can help you. I just gotta ask for it. Oh, you want help? Hey guys, on number 1, I want you to go ahead and tell me what 5 to the 3rd is. Type that into your calculator. Give me a number.
5 to the 3rd.
Well, on your worksheet. On your worksheet.
5 times 5 is 25 times 5 is 125. My bad.
Wait, I don't understand where it's just
On the worksheet. Problem number 1, I don't want you to leave your answers 5 to the 3rd. I want you to give me the actual number answer.
Oh, okay. What? I knew how to do it too, but I didn't know what we were supposed to do. I thought you were just asking me.
Which A, the first is really just. It's not.
How to do it?
Why don't you try it? Write it down. Simplify.
It's on the hair.
Write it down. Now, 2/4 is not 2. If it's 4 divided by 2, then it would be 2. What's 2/4?
Oh, it's just hard.
So it's
They made the last second half. I was like,
Not
oh,
yet.
it's not like it couldn't say that now.
Now, you have to have a fraction, because you have a D in the denominator.
Free throws because I missed one of them.
Let's rewrite it. So
Man, you
here
know
we
what?
go.
That's like 90%, 95% of my
3 out of
shot.
4, that's 75%.
Standard division.
I had
Okay,
3
when you do the
points.
4,
Hold on.
3/4
No,
and
no, 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 no.
75%.
I shot
Right.
3.
Okay, yeah, sure.
No, I shot 3 free throws, and I missed one of them.
So
That means
8
I'm
for
5 for
third.
6.
What?
B's
You
for
shoot
power.
2 free throws each time.
Yeah,
Yeah,
you shot 3.
I shot 3.
You have
You mean
2
you're
minus
3
for
actual
four.
3
minus
sets.
1 is.
Oh,
That's
okay.
what I'm talking
That's
about.
6
3
for.
sets. I'm 5 for 6.
What's going to happen to your C's? You have C
Well,
I
divided
think
by
you said
C.
you had 3 free throws.
I shot 3 sets.
No, what's C
Yeah,
divided by
3
C?
sets is 6.
Anything divided by
I
itself.
missed 1, so I was
Very
5 for
well.
6.
And you have a D
So
on
I
your
had 7,
denominator.
at
You don't
least
have
7
C.
points
Come
last
on.
night.
You have D on the denominator. Hang on, so the denominator has to
It's
say.
90-something
It's
percent.
force for a reason.
See, during practice, I
Well,
can't
five,
make,
like
I
five.
can't make free throws
Now,
for practice.
C's,
But
which I
when you
can
put
all
me in a
flip.
game, that's like the second, free throw I've missed all season.
No, he gets cocky out there. Like, as soon as you guys went out there for a warm-up during the girls' halftime, like, sprinted out there and shot an air real fast.
Yeah,
No, I'm not taking it to my
Yeah.
that way his hair
taking it to the
flips.
I thought he was gonna miss it, I was like,
Right.
then he made a leg.
His reverse.
He did a reverse layup and he went like this. He goes,
Position sign.
being stepped at the door, so he
Yes. He put so much spin.
Hang on, Chris, hang on.
Like, you
Division sign.
should
See
have
how we have a
seen
big
the
division sign right
Louisiana
here?
game.
Put negative 1 in the numerator. Big
It
division sign.
sat in the air for like 3 seconds, then it hit the back.
It spun
When
all the way
it
across
hit it,
the back
it
door.
rolled around.
Let's say he hit 2
2
reverse
seconds.
layups.
Yeah. Matt had 1.
I saw
Matt had
that.
2. Logan gets first time. It was a shot.
So negative 1 to the third power is what?
Yeah, he made 3 last night, didn't he?
No, negative 1 to the third power?
Yeah, a bunch of
What's this?
steals and a tip.
Negative 1 times negative 1 times negative 1.
Well, those
Negative 1 times
tips,
negative 1 times
see,
negative 1.
if we tip, they get nervous.
So the opposite.
Because
They were terrible at
passing. If we didn't get the ball from the tip, then they start trying
Yes.
to rush because they're really nervous
But like-
and then they make bad passes.
All their passes were either
Divide.
to
And
us
what goes
or out
into
of
2 and
bounds.
into 14?
Like, they were, I'm
Chris,
surprised
go.
they gave
Take
me,
your stuff.
like,
I don't want you to
they gave
finish.
me 10 points.
Take your stuff.
No,
Go.
it wasn't even 2 minutes.
It's 2. It goes into 2.
We won by
And
like
then 2 goes
13
into 2.
points. Well, it would have been 13 points if Matt
Well,
would
2
have
goes
freaking
right.
left the skill the ball. I don't even know
Nice.
why
Still,
they
that was like, yeah, he was like, I'm gonna get this last second layup. So,
I mean, you
That's
guys are gonna lose either way.
I would have just stole it and like, I did a 3-point line. If I air ball it across anyway.
I'm sorry, Ricky. I think you're fine. Well, you're gonna divide that line when you divide. Well, that's the name of the what goes into 2? You're taking 14. What goes into 2? 2 goes into 2 how many times? Negative, so it's negative 2. Why is that?
Do we need clickers?
I wasn't for sure if you were
You'll need clickers for questions on homework, yes.
Do we need a book or hardback?
You will have a worksheet for homework.
Okay.